Dear students, most of the reagents used in the scientific laboratory are in the form of solutions that need to be prepared or purchased. For some cases, the exact concentration of the solution is not important, while for other cases, the concentration and the method of preparation of the solution needs to be as accurate as possible. Today, we will learn how to make solutions in the laboratory. But before that, we need to get acquainted with the glassware used for this purpose. This is a glass pipette that is used to transfer fixed volumes of liquids from one container to another. The pipette that I am holding at the moment can measure up to 25 ml of the liquid. Remember that you should never use mouth pipetting for transferring liquids. Always use a pipette sucker, pipette filler, or pipette bulb for transferring the liquid. This is a volumetric flask that can be used in the preparation of fixed volumes of solutions. These flasks can only measure up to a single volume. For instance, this flask can be used to prepare a solution of 500 ml only. This single mark here indicates that when volume of the solution reaches up to this mark, the volume will be 500 ml. These flasks are available in 100 ml, 250 ml, 500 ml and 1000 ml capacities. This is a measuring cylinder. Measuring cylinders can also be used for preparation of solutions and come in various sizes with different capacities. For instance, this is a 10 ml measuring cylinder, this is a 100 ml measuring cylinder, and this is a 500 ml measuring cylinder. This is a conical flask, and like other glassware, this also comes in varying sizes of different capacities. This is a beaker and is also available in different capacities. Remember that beakers and flasks may be used while preparing solutions but are never used to define the total volume or the final volume of the solution. Whenever preparing solutions, always raise the final volume in a narrow-necked glassware, such as a volumetric flask or a measuring cylinder. Also note that when preparing solutions, always use the upper meniscus for colored liquids and lower meniscus for colorless liquids to avoid parallax error. Concentration is a measure of the relative proportion of solute and solvent present in the solution and can be measured in terms of percentage, molarity, molality, and normality. Now that we have learnt calculations, we will be preparing a 2% solution of sodium chloride. Whenever using reagents or salts in the laboratory, ensure that you read the expiry date on the bottle and read any warning or hazard instructions that are given on the label of the bottle. To make the solution, we will first weigh 2 grams of sodium chloride . transfer this to a clean beaker. Next, add approximately 30 ml of distilled water. Since we're making a total volume of 100 ml, we can use any volume less than 50 ml at this stage. Mix the solution to dissolve all the salt. Once the salt has dissolved completely, transfer this to a measuring cylinder. Next, raise the volume of this solution to 100 ml using distilled water. As told earlier, read the lower meniscus for colorless liquids. Once the solution is ready, transfer it to a labeled bottle and store it. Now that we have learned the calculation, we will prepare 50 ml of 0.5 molar sodium hydroxide solution. For this purpose, we will be using aluminium foil to weigh the sodium hydroxide. sodium hydroxide pellets get hydrated very quickly, so this step needs to be done quickly. Add approximately 20 ml of distilled water to this pellet. Mix the solution to dissolve the pellet. You will notice that heat is liberated as sodium hydroxide dissolves in the solution. If you are preparing large volumes of sodium hydroxide solution, you can do this step using a magnetic stirrer to avoid splashing. Once the pellet has dissolved completely, transfer this solution to a measuring cylinder and raise its volume to 50 ml using distilled water. Once the volume of the solution has been made up to 50 ml, transfer it to a labeled reagent bottle. Now, we will learn how to make dilute solutions from concentrated solutions. To prepare 0.1 molar sodium hydroxide solution from 0.5 molar sodium hydroxide solution, We will first take 10 ml of the stock solution, that is 0.5 molar sodium hydroxide solution. Now, raise the volume of this solution to 50 ml using distilled water to prepare 0.1 molar sodium hydroxide solution. Transfer this solution to a labeled reagent bottle. Now, we will learn how to measure the pH of any solution using a pH meter. Carefully remove the bulb of the pH meter from its solution. Immerse it in distilled water. Ensure that at any point during measurement, the bulb of the pH meter does not come in contact with the walls or base of the container. Then, wipe the bulb of the pH meter using a lint-free tissue paper. Pour the test solution in a beaker. And immerse the bulb in this solution. Allow the reading on the pH meter to stabilize. The pH of this solution is 12.68. Once you have measured the pH, Wash the glass bulb again in distilled water. The bulb of the pH meter is very sensitive and needs to be handled carefully. Once you have taken the reading, place the bulb in its solution again. This container contains a solution of potassium chloride. We will now learn the concept of normality. Normality is generally used for acids and bases. To calculate the normality of an acid, we will need information from its bottle. This is a bottle of sulfuric acid. Check the percentage purity of this sulfuric acid. The percentage purity mentioned on the bottle is 97%. Next, we need to check the specific gravity of this sulfuric acid. Specific gravity in simple terms is basically the density of this solution relative to water. A specific gravity greater than 1 indicates that this solution is heavier than water. The specific gravity mentioned on this bottle of sulfuric acid is 1.84. The portion about sulfuric acid has to come before the part about measuring pH.